Okay, this is example 4 under probability. I've done example 1, 2, 3, and this is example 4. Now, please always try to follow, always try to comment, always try to like, and always try to share for other people to benefit. Thank you. Now, in a single throw of the fair dice, find the probability that an even number appears, an odd number appears, a prime number appears, a perfect square appears, then E when a 7 appears. So let's run as usual, let X be the sample space. You know the meaning of sample space. That is the possible outcome, which is S equals to, in this case now we have a dice, right? So in that case we are going to have 1. A dice has 6 faces. A die has 6 faces. So we have phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6. This phase 1, phase 2, phase 3, phase 4, phase 5, and what? Phase 6. And what is the possible outcome of this? Is going to be 6. 1, 2, 3, 4, 5. It's going to be 6. When you hold a die and you cast it 1 time, 2 times, it might happen that the first phase might be 1, the second phase might be 2, the third phase might be what? 3, 4, 5, and 6. But it's not possible for you to cast a die and have what? And have 2 phases at the same time. It's not possible. You can only have what? A phase. Okay? Now, what is the next thing to do? An even number appears. Now, let's say what? Let E1 be the events that an even numbers appear. An even number appear. So it's going to be E of E1, which is even number appears. Now we have 2, 4, 6. So all these are the even number 4 and 6. Okay. Now what is the cardinality of E of 1? E1 is going to be 3. That is 2, 4, 6 is 3. Now the probability that an even number appear is going to be what? That is n of E1 divided by n of S. And n of E1 means what? That is the required outcome. An even number appears. So we are going to have 3 over what? Over 6, which is what? 1 over 2. Okay? So that is solution to A. The solution to B, we have an odd number appears. It tells us that let E2 be the event that an odd number appears. An odd number appears. We have odd number appears. So in that case we have odd number E2. Odd number. What are the odd number here? 1 is an odd number that is cannot be divided by 2. Okay? Odd number. 3 is an odd number. 5 is an odd number. So in that case we have E of 2 to be what? To be 3. Then the probability of an odd number appear is going to be E2 equal to n of what? N of E2 over what? N of S, which will give us 3 over 1, 3 over 6. The same like 1 over 2. So that is when an odd number appears. Now a prime number appears. a prime number appear, which is C. Let same statement, let E3 be the event that a prime number appears. A prime number appears. So we have E3 equals to a prime number. Now we have, we have number for 1, 2, 3, 4, 5, 6. So the prime number 2 is a prime number, 3 is a prime number, and 5 is a prime number. Therefore, we have E of 3, that's n of 3, we give you what? We give you 3. That is what the prime number appears. Now let's calculate the probability of a prime number appear. A prime number appear. We are going to have E of 3, then equals to what? N. E of 3, then we have what? N of x. Now what is N E of 3? That is the required outcome, which is what? 3. We have 3. Then N of x is what? The possible outcome, which is 6. Therefore, we have 1 over 1 over 2. Okay? Then the next one is what? D. Question D. A perfect square appears. So let E4 be the event that a perfect square appears. A perfect square appears. So we are going to have E4 equals to, when we are talking of the perfect square between 1 to 6, we are having what? 1 and 4. When you find the square root of 1, it will give you what? 1. When you find the square root of 4, it will give you what? 2. So 1 and 4 are what? Are perfect square. Okay? Now, what is the cardinality of this? We have is as 2. Then the probability of this is going to be PR of E4 equals to N E4 over what? N of x. Don't forget that N of E4 is what? Is the required outcome, which is what? Which is 2. Then N of x is what? Is the possible outcome, which is what? C. Therefore, this one will be 1 over 1 over 3. Then the last one is what? Which is E. 7 appears. Okay? Now let's E5 be the event that 7 appears. 7 appears. So 7 appears. Now, if you look at this sample space, is there any 7 here? No, we don't have 7s appear. So it's going to be N, it's going to be E5 equals to empty, or you put it like this. This symbol means what? Empty. It means empty. Empty. Okay? So we have the cardinality of this one is going to be E5 will give you 0. So when to calculate, if you are to calculate the probability of 7 appears, is going to be what? We have P of E5, then we have N of E5 over what? N of X, then equals to what? 0 over what? Over 6, which will give us 0. So a 7 appears is what? Is 0, because there's no a 7 on a